Good day, viewers all over the world. I welcome you to class again today. I hope you have been enjoying my videos in various topics. Once again, my name is Dr. Chris Esekaibe. I am the owner of this YouTube channel. The essence of the channel is to teach key topics in mathematics and statistics across the globe. Numerical analysis and applied statistics preferably. Please, if you have not subscribed to my YouTube channel, please subscribe to the channel. Click on the notification button so that anytime I upload a new video, you will be among the first to get the video. Share them in your social media platform, and as you do, God will bless you. Like my videos. Be part of those sharing knowledge across the globe, because that is the essence of this channel, to share knowledge in key areas in mathematics and statistics across the globe. I welcome you to class today. I am a PhD holder in mathematics, applied mathematics, and I also hold a master's degree in mathematics and a bachelor degree in statistics. I am a chief lecturer in one of the most prestigious polytechnics here in Nigeria. I work in Nigeria and I live in Nigeria. If peradventure you are an AI fan, you deal with artificial intelligence, you train AI models to understand mathematical algorithms, why not you can contact me to be part of your team of mathematicians or statisticians. I will be glad to hear from you. Or if you are a research student or a research institute, I will be glad to be part of your research. My contacts are here. The first contact is +234 80 330 21903. This first contact is for call and for WhatsApp. Then the second contact is +234 7066 297535. This second contact is only for call, while my email address is given here. I'll be looking forward to hearing from you so that I can be part of what you are doing across the globe. I've written quite a number of books. I've authored quite a number of books in numerical analysis and applied statistics. And also, I'm a member of the Nigerian Mathematical Society. It will be a privilege to be part of what you are doing across the globe. So please, let's go to the business of the day. Today we shall be looking at the iterative method for finding a root of an algebraic and transcendental equation. The equation we are looking at is a nonlinear equation. It's of the form f of x equals 0. The equation can be a transcendental equation. It can be an algebraic equation. When we talk about transcendental equations involving exponential functions, equations involving trigonometric functions, and the rest of them. And it can also be a simple nonlinear equation of the form f of x equals 0. It means that the right-hand side of the equation must be 0. So if you are given any equation whose right-hand side is not equal to 0, what we need to do is to put it in this particular form. Permit me to clean my contact. I hope you have taken note of the contact. I'll be looking forward to hearing from you. So I give an example. If, for instance, you have an equation of the form, if you have x raised to the power 3 is equal to x squared plus 5, and you are now told to resolve this kind of equation, you should understand that this equation is not of this particular format. All you need to do is to bring the quantities on the right hand side to the left hand side. You have x raised to the power 3 minus x squared minus 5 is equal to 0. So the function is f of x. So you put the particular equation in this format before you now start solving it. Now, I want to take us quickly through the iterative method. I want to take us quickly through the iterative method. Now the iterative method is as simple as you think. What the first step when using the iterative method is to rewrite the equation in the form. That's the first step. Rewrite the equation in the form. You are going to write it in this form: x equals phi of x. That is what you are going to do. You are going to write it in that form: x equals phi of x. And there is a particular test to choose, because you can have different forms of x equals phi of x from this particular equation. Now there is a rule. You are going to test for phi prime of x. The absolute value of it must be less than 1 before you know which of the phi of x to use. So this is the condition. So to choose the particular phi of x that you are to use, it must be the absolute value of phi prime of x, it must be less than 1. So in mathematics, we don't do much of grammar, we don't talk much, we explain by solving a particular problem. Now, if I say solve the following equation: f of x equals x raised to the power 3 plus x squared minus 1 is equal to 0, using the iterative method. Now you can, if you have been watching my videos on algebraic and transcendental equations, we used the bisection method in one of the videos. We used the Newton-Raphson method in one of the videos. We used the method of false position in one of the videos. And today, the iterative method is also one of the methods. So go back to those videos, see how you can use the bisection method to solve an algebraic equation, see how you can use the Newton-Raphson method to also solve an algebraic equation, and also the method of false position. These methods were used, and today this iterative method is also a method that can be used. Now, when you are given a particular problem of this nature, to find a root, just to get a root, there are some, not all problems can be solved conventionally. You can, like for instance, we use the factor theorem, the remainders theorem, when the particular equation can be factorized. You see the essence of numerical analysis. Numerical analysis has helped us a great deal. There are areas where we cannot apply the conventional method, but the numerical methods will bring solution to the particular problem. For instance, this particular problem now, you cannot factorize it, but using a numerical method, maybe the Newton-Raphson method, the bisection method, the method of false position, or even this iterative method, you will definitely get a root which the conventional method will not be able to give you. Now, you must understand that the methods that are used for solving this kind of problem, they are iterative methods. They are all iterative methods, but this is the main iterative method. The Newton-Raphson method is an iterative method. The method of false position is also an iterative method. The bisection method is also an iterative method. This iterative method generally is also an iterative method. You will get 2 points where a root lies, then you begin to use the method until you achieve convergence at a particular level of accuracy. Now, you have to be guided before you start solving any algebraic equation. You must look for 2 values where a point lies and where a root lies. For instance, you will have to get f of a and f of b comma, such that f of A and f of B are opposite in signs. When I mean opposite in signs, if f of A is positive, that is plus, then f of B will be negative. If f of A is negative, f of B will be positive. Now let's start trying. Now let's start at 0. When x is equal to 0, when x is 0, we are going to have f of 0. You are going to have 0 raised to power 3 plus 0 squared minus 1. This will give you minus 1. So f of 0 is negative. It's minus 1. So now we go again and try when x is equal to 1. When x is equal to 1, our f of 1 will be equal to 1 raised to power 3 plus 1 squared minus 1. 1 raised to power 3 is 1. 1 squared is 1. 1 plus 1 is 2. 2 minus 1 is 1. So we have been able to achieve this very quickly. So you can see that our f of 0 is negative, which is minus 1. Our f of 1 is positive, which is plus 1. So you will now come and make a comment. That means that this implies that a root lies between 0 and 1. So the root we are looking for is between 0 and 1. You know this is a cubic equation. It's expected to have 3 roots. It's expected to have 3 roots, but we have already known where one of the roots lie. So if we are able to get, using the conventional method, you will not be able to get it because it cannot be factorized. But using a numerical method will definitely give you at least 1 root. So now we want to proceed by getting x equals 5 of x. So permit me to claim this part of the board. Permit me to claim this part of the board. Remember, the problem we are solving is, let me write it out. F of x is equal x raised to power 3 plus x squared minus 1 is equal to 0. So a root lies between 0 and 1. So take note of that while I claim this other part of the board so that we can make progress and see how the iterative method works. Now, the first thing we have to do is to make x the subject of the formula, making x equals 5 of x. We are writing x. Now, at point A, we have x raised to power 3 plus x squared minus 1 is equal to 0. Now, from here you will see that x raised to power 3 plus x squared is equal to 1. Minus 1 going to the other side becomes 1. Now, you can see x squared is common between these two. So you make x squared here. If you remove x squared from x cubed, you have x. You remove x squared from x squared, you have 1. So this is equal to 1. So here you're going to have x squared is equal to 1 all over x plus 1. So taking it to the other side, x will now be equal to, you can now write it as x plus 1 raised to power minus 1. Okay, let me put the square here. Then x alone will now be equal to x plus 1 raised to power minus 1 all over 2. Or you can write it as 1 all over x plus 1 raised to power 1 all over 2, and that is equal to 1 all over square root of x plus 1, whichever way you want to write it. Then at another point, at point B, now here we have x cubed plus x squared minus 1 is equal to 0. Here you can have s cubed is equal to 1 minus x squared. So from here, our x alone will now be 1 minus x squared raised to power 1 all over 3. This is another making x equals phi of x, making x the solid of the formula. You can see it's implicit, x is also part of it. Then, thirdly, there are many ways you can make this. Thirdly, you can also have x cubed plus x squared minus 1 is equal to 0. From here, you are now making x squared the subject of the formula. This will be 1 minus s cubed. This s cubed will go there, 1 will go there. Then, of course, our x alone will now be 1 minus s cubed raised to power 1 minus s cubed raised to power, of course, 1 all over 2. So you can see that we have been able to make x the solid of the formula in 3 different ways, in 3 different categories. Now, we are going to test. This is the test equation that we are going to use. We are going to use phi prime of x naught. The absolute value of it must be less than 1. Now, we are going to test these 3 equations one after the other. We are going to test the 3 equations one after the other. Now, let us take a look at this first one. Permit me to clean this part. I want to test using that particular test inequality. Remember what we have here. Now, our phi of x from A is equal to x plus 1 raised to power minus 1 all over 2. That's the first one that we have. We are going to test it and see if it complies with this particular inequality here. Remember, we have the other phi of x. So we have 3 phi of x. This one is from A. Then the second phi of x is 1 minus x squared raised to power 1 all over 3. Then the third phi of x, this one is B, this one is C. The third phi of x is equal to 1 minus x raised to power 3 all raised to power 1 all over 2. So these are the 3 phi of x that we have been able to get when making x the subject of the formula in this. Now, remember, a root lies between 0 and 1. You can choose any value as the starting point. You can choose any value as the starting point. Permit us, we can choose x naught. Let us choose x naught is equal to 0.75. So between this 0 and 1, you will choose a particular value which we call the starting value. You have the right. Someone else can choose 0.70. Another person can choose 0.80. Another person can choose 0.5, depending on your choice. So I'm making my choice to choose 0.75. If you choose 0.8, you are not wrong. Make sure that the value you are choosing is between 0 and 1, where the root lies. And again, your choice of a starting value will also determine the number of iterations you are going to have. So now let us test use that particular test inequality to see if the first one meets the requirement. Now, if we have phi of x is equal to x plus 1 raised to power minus 1 all over 2. From here we see let u is equal to x plus 1. So this means that phi of x will be equal to u raised to power minus 1 all over 2. So from here, du over dx is equal to 1. If you differentiate u with respect to x, of course differentiating 1 is a constant, is 0. Differentiating x, you have 1. Then now differentiating phi of x, the phi of x, the phi of x all over du, because we have this here now. Of course, this one will come down. You are going to have minus 1 all over 2. Of course, you know the rule for differentiation. Then you now have u. It will now be minus 1 over 2 minus 1. It will now be minus 3 all over 2. That is what you are going to have. Now, putting x in, of course, putting the value of u in, you are going to have minus 1 all over 2 bracket. What is our u? Remember, our u is x plus 1, then raised to power minus 3 all over 2. So that is what we have there. Now, we are looking for, note, we are looking for the phi of x all over dx. That will be equal to the phi of x all over du times du all over dx. What is our d? Phi of x all over du is minus 1 all over 2 into x plus 1 bracket minus 3 all over 2. Then times du over dx is 1. So you are going to have minus 1 all over 2 into, of course, x plus 1 bracket minus 3 all over 2. So you can have it as minus 1 all over, of course, this 2 is there. When this is coming down, you now have x plus 1 raised to power 3 all over 2. That is what you are going to have there. You are going to, so now, that is what our phi, that means our phi prime of x will now be equal to that minus 1 all over 2 into x plus 1 or raised to power 3 all over 2. Now, choosing x naught as the starting value, which is 0.75, this will now be equal to, of course, you know that we are taking the absolute value of it from what the inequality says. So you are going to have minus 1 all over 2 into 0.75 plus 1, then all raised to power 3 all over 2. So you are going to have, by the time you carry out that out, you are going to have the absolute value of minus 1 all over, if you 0.75 plus 1, it will be 1.75 raised to power 3 over. So you are going to have 2 into 1.75 raised to power 3 all over 2. So 1 all over that. Then taking the absolute value, you are going to have, when you carry out this expression, you are going to have 0.216, and that is absolutely less than 1. So this particular first equation here can be used. It has satisfied this particular test inequality. So we can use this particular first one. So I hope you have seen how we were able to prove it. So now we are going to see how we can clean the board so that we can have enough space to write. Permit me to clean it off so that we can have enough space to write. Remember, our starting value is 0.75. Our x naught is 0.75. So permit me to also clean all these parts. So now the equation we are going to use, we are going to have our x n plus 1 is not equal to this. We are now going to use x plus 1 all raised to power minus 1 all over 2. This will be xn here because it's iterative. So we can now come and have our xn plus 1 is equal to 1 all over square root of xn plus 1. So this will now be the iterative equation we shall be using to solve this particular problem. It's not going to be the iterative equation that we are going to be using. Remember, our x naught is equal to 0.75. Our x naught is 0.75. Now we want to start iterating. Now when n at the 0th iteration, n is equal to 0. Now we are going 0 plus 1 is 1. Our x1 will be equal to 0 plus 1 is 1. Our x1 will be equal to 1 all over square root of x naught plus 1, and that will be equal to 1 all over square root of, what is our x naught? 0.75 plus 1. So we are going to have our x1 will now be equal to 1 all over square root of 1.75. When you have that, you are going to have x1 will now be equal to 0.755929. We are taking it up to 6 decimal places. You can see 0, that's what we have as our x1. So now we move again at the, when n is equal to 1 now, you are coming here at this particular point when n is equal to 1, 1 plus 1 is 2, our x2 will be equal to 1 all over square root of n is 1, x1, so we have x1 plus 1, that will now be equal to 1 all over square root of, what is our x1? Our x1 is 0.755929, of course, plus 1. We extend the roots, so we put it here 1 all over that. So our x2 will be equal to 1 all over square root of, you add 1 to that, you have 1.755929. And when you get the square root of this, and of course you divide it, and you have that particular value. You now have your x2 to be 0.754, 652. So our x2 will be that particular value. So permit me to clean this part so that we can continue to make progress. Permit me to clean this part so that we can continue to make progress. So if we now come here, when n is equal to 2, when n is equal to 2, so 2 plus 1 is 3, our n3, our x3, rather, x3 will be equal to, because n is 2, 2 plus 1 is 3, our x3 will be equal to 1 all over square root of xn. n is 2, x2 plus 1, that will be equal to 1 all over square root of, what is our x2? 0.752652 plus 1, and that will be equal to 1 all over square root of 0 of course when you add 1 to this, it will be 1.755652. So when you take the square root of that and carry out that mathematical expression, our x3 will be 0.754 926. That will be our x3. Permit me to clean this part also so that we can continue. Now, when n is equal to 3, now our xn plus 1 will be x4 is equal to 1 all over square root of n is 3, it will be x3 plus 1. So our x4 will be equal to 1 all over square root of, what is our x3? 0.754926, of course, plus 1. So our x4 will be equal to 1, I'm able to write this one very well, 1 all over square root of, when you add this to this, it will now be 1.754926. Now remember, we are working with 6 decimal places. So from there, our x4 will be 0.754867. So permit me to clean this part of x2. I'll also clean this part. Remember, our xn, let me write it here, xn plus 1 is equal to xn is equal to 1 all over square root of xn plus 1. So now, when n is equal to 4, our n plus 1 will be 5, so we have our x5 will now be equal to 1 all over, this is the formula we are using all through, 1 over square root of n is 4, so it will be x4 plus 1. So we are coming now to have it as 1 all over square root of, what is our x4? Look at our x4 here, 0.754867 plus 1. So our x5 will be equal to 1 all over square root of 1 point, when you add that, 1.754867, and when you carry that arithmetic out, you get the square root of the denominator, and carry out the simple arithmetic. You are going to have 0.754 So you can see, you go on and on and on. You can see at 3 decimal places we have been able to at least achieve convergence. 0.754 is converging, it has started converging at 3 decimal places. Not even 3, even 4. 0.7548. 0.7548. You see that at 4 decimal places it has started converging. You take more iterations as you begin to go and go, you see it converging at 5 decimal places, 6 decimal places, and so on and so forth. So at, you can see it now, it has, that means x has started converging at 0.7548 and so on. It has started converging. So that is the root we are looking for. Note, it is an iterative method, and every iterative method, what we look for in an iterative method is convergence. So you can see now, initially from x0, x1, we're having 2 decimal places of convergence. You go to 3 decimal places, 0.754. It now got to, even got to 0.754926, and so on and so forth. Then it now came down to 0.75486. 0.7548. So you can see at 4 decimal places we have been able to achieve convergence. Just a root. It's just a root we are looking for, not the 3 roots. It's a cubic equation, it's expected to have 3 roots, but if you are to use a conventional method, you will not be able to achieve it, because it cannot be factorized. Maybe using the factor theorem or the remainders theorem, it can be factorized. So hence we resort to a numerical method. So you can see the importance of numerical analysis, using numerical or alternative approach to getting a particular problem solved. You can see it's in decimal, the root is in decimal. Of course, if you take more iteration, it will definitely converge to maybe 6 decimal places, 7 decimal places, and so on and so forth. So we have solved up to the 5th iteration at x5, and we have been able to achieve 4 decimal places level of accuracy. So beloved, I hope you have seen how the iterative method can be used to solve an algebraic equation. It can also solve a transcendental equation. All you just need to do is to follow the step, use that test inequality, phi prime of x, the absolute value of it must be less than 1. Picking, you must choose a value of x naught. You will definitely get 2 points where the root lies. Like for this particular problem, the root lies between 0 and 1. So we chose 0.75 as our starting value. So you have the right to choose your starting value when you have eventually gotten the 2 points where the root lies. So, and you begin to iterate. The essence is to achieve convergence. And when convergence is achieved at a particular level of accuracy, you are permitted to stop. So the main thing is to understand how the method works. You can also use the Iterative method to solve this problem on your own. You can use the method of first position. You can also use the bisection method. These methods were taught, they have been taught in my YouTube channel. You will see the videos there. So please, if you have not subscribed to my channel, subscribe to the channel, share my videos in all your social media platforms, and as you do, God will bless you. For those of you who have subscribed, thank you for sharing the videos. Thank you for subscribing to the channel, and God will bless you on every side. Once again, if you are an AI firm, you can contact me. I'm a mathematician and also a statistician. I deal with a lot of mathematical algorithms, especially in numerical analysis and statistical computing or applied statistics. You can contact me, or you are a research firm, or even you may be a research student, an MSc student in numerical analysis. I have seen 1 or 2 of them contacted me, one from Uganda and from the other parts of the world. And also, if you're an AI firm, you train AI models, you want them to understand mathematical algorithm better, why not? You can contact me. I can also help you to train the models as a mathematician. Please contact me. I'll be looking forward to hearing from you. My contacts were displayed at the beginning of this video. I'll be looking forward to hearing from you. Thank you for watching patiently and waiting to see the end of the video. I know by now you understand what the iterative method is for finding a root of an algebraic or transcendental equation. God bless you. Enjoy the rest of the day. Bye.